Good morning, all. In the last class, we have gone through the fundamental concept of the AC circuit. But in that class, we have discussed different terminologies: average value, what is RMS value, and what is frequency, and what is meant by time period, cycle, and why we prefer to go for the AC system rather than the DC system, and what is the advantages of by taking the sinusoidal waveform instead of going with the triangular waveform or rectangular waveform and other waveforms. So those kind of concept we have discussed in the last class, and this today's class will go to that concept here called if single phase supply to a pure resistor If you supply a single phase AC system to a pure resistor, then what could be the consequences which is going to be happening inside that circuit? So for this, so let us going to take a pure resistor of it has the resistance R, and for this pure resistor a single phase AC supply system has been connected, and this is providing a single phase AC supply system. So this is Vm sin omega t, and this is the what the current I is flowing through this resistor. So if you say here, so this is the instantaneous voltage, or you can say it is instantaneous current, but this voltage, this AC voltage can be represented into a phasor form or vector form, can be represented into a phasor form, that is I can write as a V. V is a voltage, AC voltage, which is representing into a phasor form. And we also know that the phasor form, phasor quantities measures in RMS values, or you can say phasor quantities are represented with the RMS value. So whatever the V is given, that is also nothing but I can say it is a VRMS, something like this. Then what is the VRMS for a sinusoidal waveform? What is the VRMS for sinusoidal waveform? In the last class we have derived that. So we got this is Vm by root 2. So this is what the phasor quantity representation of the AC voltage in terms of vectorial form. And if you draw the same sinusoidal waveform, this sinusoidal waveform into a pictorial diagram, something like this. So some diagram in a waveform like, so this is nothing but my sinusoidal waveform. So this is my sinusoidal waveform, and I can say this is a instantaneous voltage, that is Vm sin omega t. Suppose I want to calculate this instantaneous current. So what could be the value for instantaneous current? That is nothing but this instantaneous voltage by the resistance R. If you do this, then you will be able to calculate what is I, the small I letters, that is. So what is this V? Again Vm by R, and it is again coming sin omega t. If you simplify this equation here, then you are able to get Vm sin omega t, where you can say that this my this Im is nothing but this Vm by R. So this is what the relations we have. So if you see here, my instantaneous voltage is a sinusoidal waveform, this one, sinusoidal waveform, and my instantaneous current Im sin omega t, this is also a sinusoidal waveform, but my amplitude of Im may be different here. So it may be different. What could be the different value? Vm by r. Vm by r is the magnitude of my Im. So obviously, as compared to this instantaneous voltage waveform, my instantaneous current, the sinusoidal current is magnitude is lesser, but it is going in phase. Because it is a Vm sin omega t, and this is also Im sin omega t. The phase angle between your instantaneous voltage and current, there is no phase angle difference, so both are going in the in phase, but the thing is there is a difference in amplitude. So that is I want to talk here. So this is I can write this is Im sin omega t. This is Im sin omega t. Now if you represent the phasor current, in the same vector here, so here it can become something like, here my phasor current may be coming here. This is my phasor current I. Your V and I going in phase. There is no phase difference is there. So this is the vectorial representation. This is the waveform representation of your V and I for AC quantities. So again this I is nothing but a phasor representation. This is also I is a RMS value. So I can write this is Im by root 2. I can write this is a RMS value. What is the sinusoidal RMS value for this sinusoidal signal? This is Im by root 2. So this is how the vectorial diagrams coming into this picture. Then what could be the power consumption? We need to understand here. So the power consumed by this circuit, that is I can say the P. So that the power consumed I can write, if it is instantaneous power, then this is multiplied by instantaneous voltage into instantaneous current. This expression you already know. Power is equal to V into I, or power is equal to I square R, or power is equal to V square by R. So different expressions we have to calculate the power. So I am using this. This is the one of the expression to calculate the power, which is in terms of voltage and current. So this is my instantaneous power. V and I is coming like this. So it is the multiplication of your instantaneous voltage and multiplication of the instantaneous current. If you multiply or product of these two waveforms, if you do product of these two like that, if you do this one, so this is my power waveform. Even if you go to the negative side also, as well, here the negative into that negative, again this will come as a positive value. Negative into negative value, again product of these two, again coming the positive value. So again for product of these two also, my waveform comes like this. So this is, it means for a complete cycle of this AC system, my power is getting the positive values, or oscillating double the frequency, I can say. So this is my power. This is V into I, or it is also called a instantaneous power. So what some points we observed here is, for whenever is this power is measured, for a one cycle, so that time my power cycle is double. It means my frequency of power is double, or twice the fundamental frequency. So that is what we observe. So whenever this circuit has been connected in an electrical network, and I want to measure the power, therefore what happens is, in general we are going to use the wattmeter. I want to measure the power, we are going to use a wattmeter. Wattmeter is going to use to measure measure the average power. So why it is going to measure the average power here is, so if you going through this circuit here, so this is the instantaneous varying value. These are the instantaneously, for every instant this power is varying, but I want a fixed value for a power consumption. What could be the power consumption at t second, for a time given time t, what could be the power? So it should not be varying one, but we need to get some fixed value to understand what could be the power consumption by the resistor. So therefore generally wattmeter used to measure the average power, and you know what is meant by the average power. The definition you have already gone through that, so that there is no issue. So this is what wattmeter is going to measure the average power. So now we will see. Now before going to see how that wattmeter measures the average power, we have to see what could be the instantaneous power which is coming from your this network. So this is the instantaneous voltage into instantaneous current. What is this V here? This is nothing but Vm sin omega t multiplied by Im sin omega t. Im sin omega t I can write. If you do the simplification of this equation, then you are going to get this kind of equation. Again, if you do this one further, it is going to come something like 1 minus cos 2 omega t. If you could remember the trigonometric formulas, so this is sin square theta is equal to 1 minus cos theta by 2. So this is what we are getting. So this is that again the instantaneous power. This is Vm Im by 2 minus this Vm Im by 2 cos 2 omega t. So what I try to talk here is, because if you say this one, so this is called, here omega is nothing but 2 pi f. 2 pi f, where is f is a fundamental frequency. You know this one, what is f. So 2 omega means this total term is the frequency is, for this total term frequency is twice the fundamental frequency, or you can say your power, instantaneous power is oscillating, double the frequency. So this is what the mathematical explanation. If you see the diagram here, so this is what the double the frequency you can able to see here. Suppose my fundamental sine wave is taking some it is completing one cycle. So within this one cycle, my instantaneous power is completes the 2 cycles. So that is what my instantaneous power is doubling the frequency, or it is oscillating with twice the fundamental frequency. So this is the concept I want to talk. So this is what the mathematical expression you are getting for the if you would calculate the instantaneous power, but in actual sense we are not going to use this instantaneous power. We require a average power, because we need average power, because at every instant your power is varying. So we need to fix a fixed value. Whether at any instant time what could be the measuring power. It is a 2 volts, it is a 2 watt, or it is a 5 watt. So that kind of instant power I needed, but I doesn't want that varying power from 0 to 10 watt. It is varying. So that kind of that condition is not recommended for us. So we need a fixed value to measure the power. So that's why we are using that wattmeter to calculate the power in any electrical circuit. So remember, our wattmeter always reads a average power. So we'll calculate what could be the average power. Now we'll calculate calculate what is the average power now. What is the expression for this average power? We'll see this one now. So if you want to talk what is this average power, if you go back and if you recall your average value definition, where you have given this formula, that is the area under the curve by the total base value. So that formula, if you recall that, so from this point, if you write the expression for this, then I can write this is nothing but the total time period 2 pi, and it is integration 2 to 2 pi, and my instantaneous power, this is instantaneous power small p, this is the capital P, this is capital P, and this is small p, this is the instantaneous power. This instantaneous power and dt I can write, so dt. So this is how I can calculate the average value for this power. So you know this what is this pi here. So this instantaneous power equation, so you can substitute this value here. You can take this one and substitute here, and you are going to get Vm by 2 into 1 minus cos 2 omega t. Now further, if you simplify this one, if you simplify this concept here, so what you're going to get here is, you get some Vm by Im by 4 pi, and if you do this integration 2 to 2 pi dt. So this is simply a trigonometrical simplification or solution you can able to do to solve these expressions here. So you can do yourself if you are well familiar with the trigonometrical expressions here. So this is what, and finally I can write the P average, capital P average power, which is measured by the wattmeter, Vm Im by 2, Vm Im by 2, or I can write this is Vm by root 2 into Im by root 2. I can use, isn't it? What is the relation between is Vm by 2 into Im by 2 here? So I can make it into the some simplified equation here. So what is Vm by root 2? That is nothing but Vrms, and what is Im by root 2? That is nothing but Irms. You know this one. So otherwise I can take, this is the P, this is the average power. P is nothing but the phasor voltage into your phasor current, V into I, phasor voltage into phasor current. Because phasor voltage is also equal to Vrms in case of AC quantity. So this P is equal to Vi. So this is what the power measured by wattmeter. Here we need to understand a small concept is called, we need to understand what some power factor concept here. So the power factor definition is nothing but it is a cosine angle between the voltage and current. So this is the definition of the power factor. If you talk generally, power factor means cos pi. Cos pi is called a power factor, where your pi is nothing but the angle between your voltage and current. So if you recall what is the angle between your voltage and current, if you go back and if you see what is the angle between your voltage and current, what is the angle between your voltage and current? Because your voltage and current are in phase, both are in phase. If you see this diagram also, this voltage and current, this voltage and this current are in phase. So the angle between your voltage and current, I can say it is a 0. So the pi is 0 here. The phase angle between your voltage and current is 0 degrees. So cos pi 0, this is cos 0 is equal to 1. 1 is a power factor if it is a purely resistive system, or you can say if it is a cos pi is equal to 1 means it is a unity power factor. Unity power factor. So this is the concept. Unity power factor means your load is purely resistive, where your voltage and current, there is no angle between the voltage and current. Both voltage and current are in phase. So this is what you need to understand here. And small concept again we give here. In case of DC system, if you measure the power, that power is nothing but simply multiplication of VDC voltage and IDC current. VDC and IDC current. There is no power factor concept will arises. But when comes to your AC system, your power can be measured, that is coming with this Vrms, Irms, and multiplication of angle between the V and I, that is cos pi. So this is exactly the expression if you are getting, if you talk generalized expression. But for this expression, if you write P is equal to Vi cos pi, and if it is writing for purely resistive circuit, but for purely resistive circuit P is equal to V into I, but for purely resistive circuit my cos pi, the angle between the voltage and current is in phase, cos pi is 0, so this is coming like value is 1, so that my power is equal to simply Vi. So this is how you are going to measuring the power. This both are the same. These both are, you can say, have the same value. So you can say the same meaning. You can talk something like this. So this is what the purely resistive circuit. If you take the purely resistive circuit, which is for which the AC system, AC quantity is applying, so it is going to consume the power, and this is going to consume the power. I can say the first note. So the resistor consumes that power, that power is called the active power. So whatever the power consumed by the resistive system, or the power which is generated by your AC quantity, that is the active power. And purely resistive, then cos pi power factor is 1, and it is called unity power factor. That point also you have to note it. And the third point is when that V and I are in phase if the load is purely resistive. So we'll take one numerical, and you can easily understand what are the different quantities, and how you can get the relation between the system. So this is the single phase 250 Hz voltage is applied across the circuit, consists of pure resistive of 20 ohms is there. So in that they are asking to calculate current flowing through the circuit. The second, they are asking to calculate power absorbed by the network or resistor by the circuit. What is the power calculation? Third one is they are asking to calculate instantaneous voltage and current. What could be the expression for internal voltage and current? So these are the three concepts they are asking to do this one. So I can take the solution. So given is the voltage has been given. Remember in AC quantities, if the voltage is given, this voltage is nothing but a Vrms voltage, because in AC quantities your voltage can be measured in Vrms. So whatever the voltage is given, you can take it as a Vrms voltage, and the frequency is 50 Hz frequency, and R is 20 ohms. So this is the things has been given. If you draw the diagram for this, so this is what my diagrams look like. This R, you can say the diagrams look like this, and this is my instantaneous current, and if you talk, this is my instantaneous voltage, then this is nothing but I can say Vm sine omega t, or you can say this is nothing but Im sine omega t, where my R is equal to 20 ohms. These are the some kind of things has been given to us to calculate. But in the first question, what is asking to calculate is, they are asking to calculate what is the I. That I is nothing but this is IRMS value or current in this circuit. So this is nothing but V by, I can take R. This is nothing but 250 by, you can take, it is 20, then it is coming 2.5 amperes. So this is the first thing you can to understand here. The next part, the second part, they are asking to find what is the average power. That is nothing but again V into I, you know. So V is nothing but IRMS and I is nothing IRMS this part. So 250 into 12.5, if you do this one, if you are getting 3125 watt, or sometimes it is also converted into kilowatt, then 2.15 kilowatt. In the third point, they are asking to find instantaneous voltage. This is nothing but Vm by sine omega t. But actually, what is this Vm? I can convert that Vm into I can convert into root 2 Vrms into sine, where instead of omega 2 pi into f into t I can write. So you know root 2, what is Vrms? 250, and sine omega and 2 pi into 50 into t. So this is, you are getting, the solution is 353.6 sine 314 t. So this is called the instantaneous voltage. Can you do the instantaneous current equation? So this is instantaneous current equation you have, and here also you can write R2 into Im, sorry, this is IRMS and sine omega into 2 pi ft, something like this. So you can do, what is IRMS again? It is 12.5, and sine omega, this whole thing I can write 314 t. So again it is coming 17.6 sine 314 t. So this is my instantaneous voltage and instantaneous current, and the average power, and that AC quantity or IRMS point and IRMS voltage. So these are the how you can able to calculate the voltages all about the quantities. So this is what the today's session. In the next class we are going to take purely inductive part and what could be the behavior of the circuit, that kind of thing we are going to discuss in the next class.